What if a mountain of ice slowly decided to flow like a river, reshaping the land beneath it? A glacier is not just frozen water, it is nature moving mountains at its own pace. In this video, we are going to explore one of the slowest yet most powerful natural processes on Earth, glacier movement. Glaciers appear solid and unchanging, but they are constantly on the move, carving valleys and shaping mountains over centuries. On this channel, we explain nature calmly and truthfully, without exaggeration or fear. Glaciers are the Earth's slow sculptors, moving silently but leaving lasting impact. Today, you will learn how glaciers form, why they move, and how they shape the land around them. Stay until the end to truly understand why ice can be as powerful as fire or water. How glaciers form. Glaciers begin with snow accumulating year after year in cold regions, such as high mountains in polar areas. Each new snowfall compresses the layers beneath it, squeezing out air and slowly transforming soft snow into dense, solid ice. Over thousands of years, this growing mass becomes incredibly heavy. Once the ice reaches a critical thickness, it begins to deform and flow under its own weight. Though the movement is extremely slow, the pressure stored inside the glacier is immense. Nature patiently builds glaciers as reservoirs of frozen energy, storing force over long periods of time. The role of gravity. Gravity is the main engine behind glacier movement. As the ice mass thickens, gravity pulls it downhill, causing the glacier to slowly creep forward. Unlike rivers, glaciers do not need liquid water to flow. The ice itself deforms internally under pressure. This movement may only be a few centimeters per day, but over centuries it is enough to reshape entire landscapes. Valleys deepen, mountains are worn down, and the land gradually changes form. Gravity works quietly, guiding frozen rivers across the Earth. Types of glacier movement. Not all glaciers move in the same way. Some glide smoothly over bedrock, helped by a thin layer of meltwater beneath them. Others move through internal deformation, where ice crystals slowly shift and slide past each other. In certain conditions, glaciers can surge forward rapidly, moving much faster than normal for short periods. Cracks called crevices form where the ice stretches or accelerates, revealing stress within the glacier. While every glacier behaves differently, all follow the same physical rules of pressure, temperature, and gravity. How glaciers shape the land. Glaciers are among the most powerful sculptors of the Earth's surface. As they move, they scrape and grind the rock beneath them, a process known as glacial erosion. Over time, this carving creates wide U-shaped valleys, deep fjords, and smoothed mountain slopes. Glaciers also transport massive amounts of rock and soil, carrying debris over long distances. When the ice melts, this material is left behind in ridges called moraines, marking where glaciers once flowed. Even after they disappear, glaciers leave permanent signatures on the landscape. Why glaciers move faster in some areas. Glacier speed depends on several factors working together. Steeper slopes allow gravity to pull ice more quickly downhill. Thicker ice create greater pressure at the base, increasing movement. Temperature also plays a key role. When ice near the bottom reaches the melting point, a thin layer of water forms, reducing friction and allowing the glacier to slide more easily. These conditions combine to create areas where glaciers move faster, even though the overall motion remains slow compared to rivers. Mid-video retention. Before we continue, remember this: even though glaciers move slowly, every centimeter of motion carries enough force to reshape mountains. What happens next explains why this slow movement matters to life far beyond the ice itself. The impact of climate. Climate strongly controls glacier growth and decline. Cold temperatures and heavy snowfall allow glaciers to expand, while warmer conditions lead to melting and retreat. Seasonal changes affect surface melting, but long-term climate trends determine whether glaciers survive or disappear. Today, many glaciers around the world are shrinking due to rising global temperatures. Studying glaciers helps scientists understand how sensitive Earth's systems are and how changes in climate can affect landscapes, oceans, and ecosystems over time. Glaciers and water supply. Glaciers act as natural freshwater reservoirs, storing water in frozen form and releasing it gradually as they melt. This slow release feeds rivers and streams throughout the year, especially during dry seasons when rainfall is low. Millions of people rely on glacier-fed rivers for drinking water, agriculture, and hydroelectric power. When glaciers shrink too quickly, this balance is disrupted, reducing water availability and affecting communities far downstream. Can glaciers be predicted? Scientists monitor glaciers using satellites, GPS instruments, and field measurements. By tracking ice thickness, flow speed, and mass balance, researchers can understand how glaciers are changing over time. While glacier movement is slow, careful observation allows scientists to predict future water supply, sea level rise, and environmental impacts. Understanding glaciers helps humans respond thoughtfully to long-term changes rather than reacting too late. A glacier is frozen water in motion, slowly reshaping mountains and valleys. It is not static, it is a powerful force of nature acting over centuries. Understanding glaciers allows humans to respect ice, predict water resources, and see the long-term impact of climate. If this video helped you understand glaciers better, like and subscribe for more calm explanations of natural processes. Comment below which phenomenon you want next, and share this video with someone who loves mountains and ice. Here, we don't fear frozen rivers, we understand them.